today we're going to determine the equation ourselves when we're given a graph. So far up until this point, we were always given an equation, and then we graphed it by transformations. So what you have here to begin your notes is the thought of considering if we had a sine graph or a cos graph, our horizontal transformations, let's just keep in mind, our horizontal transformations are our k values. And so if we had a sinusoidal graph and transformations were happening horizontally, compressions or stretches, that means that they would be getting wider or skinnier in the x-axis. Now, if we were talking about our vertical transformations, and we were using our sinusoidal graph as well, our vertical transformations, same things occur, but they happen in the y-axis. And that's affected by our a value in our graph. So horizontal transformations make changes horizontally only, no vertical changes. Vertical transformations make vertical changes only and no horizontal changes. So when we look at both of these scenarios, both scenarios here with k and a, what do we notice about our y-intercept? Our y-intercept here. Our y-intercept with our stretches and compressions does not change. And that's going to be a good thing to know when we have to write the equation. The y-intercept does not change. The only time that our y-intercept begins to change is if we start to have our p or our q value affect things by moving it up and down or left and right. So what I had come up here for your notes is that your y-intercept is going to be a perfect point to look for when trying to determine the phase shift. Keep in mind with phase shift here, with your phase shift, that is your p value. That's your left and right movement. So we'll just ask ourselves, where has the y-intercept moved to? So we can do a sketch to see that. So if we had a transformation graph that looked like this and finished here, this was 30 degrees, our y-intercept started at the origin for our sinusoidal graph. So if it's over here, we know we had a phase shift of 30 degrees to the left. So if we had to write this in our sinusoidal equation, we have theta plus 30. So the next question we're going to need to ask ourselves when we're investigating graphs is, how might we find the vertical translation? And vertical translation here just means how much up or down our graph has moved. And our up and down is represented by Q. So if we went back to this quick sketch up here above, there was no vertical translation at all. The graph is still starting on the x-axis, where the axis of curve is at y equals 0. So in order to figure out how much a graph has moved, we can investigate our equation of the curve. So if we look here, say that this is 10, 15, and 5 on our y-axis, if these were the points. Our equation of the curve that always goes in the middle of our sinusoidal graph, leaving us with the same size amplitude up and down, our same peak and trough. The equation of the curve has moved 10 units up. 10 units up. So that also must have been our Q value, because look here, our graph started right at y equals 0 here. That's also the equation of the curve. If we take this point and it has moved up 10 units, it's now sitting on the equation of the curve. So if our equation of the curve is y equals 10, then so is our Q value. So I'm just going to add in a little bit of words here for your notes. So we'd find the axes of the curve would be the first thing we do if we need to look for Q, or look where the x-intercepts have gone, because it is only affected by the vertical translation and not the vertical stretch or compression at all. Trying to use other points to find the phase shift or vertical translation are not practical because they are affected by other translations and stretches. It'd be too difficult to figure out how much the change has happened because of the stretch. So just find your y-intercept and your x-intercepts and you can figure out P and Q. Let's do one other example together here and hopefully see if we can make this a little bit more clear for you. So here's an example that we can start with, and I always find it easiest to get organized by first finding the equation of the curve, so where the line goes through the middle of the graph, and in this case here, it is at y equals 0, and I know that because my amplitude is the same for my peak and my trough. So my equation of the curve is y equals 0. My amplitudes, the size of the peak and troughs, are 2 units long. And then I look to see how long one cycle is. So when I go to look how long one cycle is, I can first decide whether I'm going to investigate this as a sine graph or a cos graph. So for this example, I'm going to first look at it as a sine graph. And either way will get you the exact same length of a cycle. So there's the sine graph. Got a little neater. Okay. So from negative 90 to 270 degrees, 360 degrees has gone by. 360 degrees. So in order to figure out my K value, I'm going to have to take 360 divided by 360, which is 1. And we know that from our previous lessons that a cycle is going to just have, the K value is just going to be 1 because it remained at 360 degrees. Now I'm going to look to see whether there was any vertical translations. Did my equation of the curve move up or down? And it didn't, because my equation of the curve is still at 0. That means that my Q value is also going to be 0. Last but not least is the phase shift. We know that a basic sinusoidal graph always starts at 0, 0. So we can clearly see the point is not there anymore. What we want to look at is how far left or right it moved. And this moved left 90 degrees. So left 90 degrees, which means it is negative 90 there. So now we have enough information that we can start to plug into our function. A sine K theta minus P brackets plus Q. Our A value is 2. Oh, but it opens down. Our sine graph normally opens, so that means that we have to be aware that this must be negative. There is definitely a reflection in the x-axis. Sine, our K was 1, so we don't even have to represent it. Theta minus negative 90 becomes theta plus 90 in the equation. We know that that still goes left. And it didn't move up or down at all, so plus 0, don't even have to show it. So now when we're given a graph, we can come up with the equation ourselves. Just like that.